All right, one of the only things that seems to have tripped us up a little bit on the test is identifying vector direction precisely. I saw a ton of people making estimations and guesses that were really, really strong, but I didn't see anybody, and that's not true. I saw only a small portion of the class using actual trigonometric ratios to find exact angle measures that show exactly what direction a vector is pointed. So let's look at what this looks like, and we'll start over here with this simple one, 2, 9. So if we were to draw this out, it's up here in quadrant 1. 2, 9 would be something like 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, okay, way up here. So that's a pretty steep vector. If I were making like a totally just an estimation of what direction that's pointed, a little bit less than 90, so maybe pointed in the direction of like 80 or something in that range. So this can become tricky, but you just use the same style of like drop in altitude to make a right triangle that we've been doing over and over in here. So the base of that triangle is 2, the height of that triangle is 9. So if we're trying to find this central angle right here, then what we're going to do is use the ratio that compares the two sides we have. If you want to go ahead and find the magnitude of it and then use something as the hypotenuse, you can. But also, like, this is the opposite side, this is the adjacent side, and there is a ratio, tangent, which will let us compare opposite and adjacent sides and then determine what the angle is. So, from here, I know that the tangent of this angle, whatever it is equal to opposite over adjacent, so 9 over 2. You guys at this point are actually really, really good at helping you figure out how to find the angle. Think to yourself what it would be. If you said arctangent, you win. You'll use arctangent of 9/2 to find what that angle theta is. I brought my calculator, so we'll do this for us real quick. Arctangent of 9/2. 77.5 degrees. Rounding a bit. And that makes sense. That's like really close to what we estimated. I estimated 80 degrees a moment ago. And that means that my estimation like squares up with what I was picturing. So one of the things that you can recycle from our earlier understanding is your knowledge of, because of the way that we view angles in the coordinate plane, we treat everything in the same like directions as we use the unit circle, which means that that earlier idea that we had, that this x or horizontal component is always the adjacent and the y component is always the opposite, that's true still. So let's go over here, let's draw this guy out and see if we can figure this one out. -4, -1. That is going to be over here, -1, 2, 3, 4, and -1. So the arrow looks something like this. That vector is pointed down and to the left. If I were to estimate this, so if this is 180 degrees, it's a little bit more than that, so 195, maybe 200, somewhere in that range. So I'm expecting it to come out to 195, 200, something like that. I also know that this is going to be the adjacent side, and this is going to be the opposite side. So that means I can set up tangent without really even having to draw the triangle if I want. Tangent of this angle, theta, is going to be equal to opposite over adjacent, so that's -1 over -4. So, think again, we've done this before, but to find the angle, you'll use arctangent. Tangent, -1 up. -1 over 4 should give us our angle theta. Let me plug into the calculator and see what I get. So arctangent of -1 divided by -4. This is weird. It gave me, plug in and see if you get this too. Seriously, pause the video, plug it. It gave me 14.03, so 14 degrees. But that doesn't make any sense because I know that it has to be more than 180. I actually know why this happens. I'm wondering if you do too. If there ever was a time to pause the video, raise your hand and flag me down for an explanation and see if you can explain it to me, this would be the one. If you're not willing to do that, then stay tuned. So this particular angle says that it'd be 14 degrees. If you think about where 14 degrees would be, 14 degrees would be up here. It's like it's exactly opposite of what we need. So if you're thinking well, you might have already figured out a solution. But let's figure out why this happens first. So we're finding the arctangent of -1 over -4. Do you all agree with me that -1 over -4 is the same as 1 over 4? Like negative divided by negative is the same as positive divided by positive. If that's true, how does your calculator know whether you're evaluating -1 over -4 or +1 over +4? It doesn't. And so as a result, your calculator will often spit out answers that are really tightly related to what you are looking for, but are not the exact same thing that you are looking for. And this is why, like, as a thinking human being, you must think through the reasonability of your answers before you just provide them. In this case, 14 degrees is not going to be the right answer, but since it is exactly opposite of what we're looking for, since it's giving me the positive equivalent of this, all I have to do to go and find the negative equivalent is take this, and like I can see that I would add 180. And it's not always that simple, so you want to make sure that you are thinking through like what is the common sense way to solve this problem. But in this particular case, it's as simple as taking this and adding 180 degrees to it. So in other words, 194 degrees. Check out my estimation gain. Didn't I say 195? All right.